we're going to get into evaluating functions, and so you'll be able to evaluate a function given any value in its domain. First of all, let's talk about what a function is. A function from x to y is a relationship where your x and y are ordered pairs, and the same x value has to have the exact same y value. So if you have the x value of 3, you cannot have 3, 2 and 3, 4. If you're going to use the same x, you have to use the same y. The x is the independent, and the reason we call it independent is because you can pick whatever you want. So a lot of times we'll say, plug it in for x. It's because it's independent. You decide. Okay? But your y dependent is because your y depends on what x was to begin with. So you can't just pick your y value. You can pick your x, plug it in, see what happens, but your y just depends on whatever the x happened to be. A lot of times we'll say, well, decide if it's a function graphically by applying the vertical line test. And again, visually speaking, it really isn't a rule of thumb. It just kind of helps you start thinking and getting into the correct mindset. There's my line. And I'd say, okay, is this a function? Does every x value have the exact same y value? And you're like, oh, I don't know. What you can do is you can apply what we call the vertical line test. The vertical line test says this: draw or think about a vertical line going through your graph. So here's a vertical line. Okay, that vertical line should only intersect your graph one time. And if it does, you would say, yes, it's a function because it passes the vertical line test, abbreviation for vertical line test. Okay, let me show you another graph. Parabola. Again, let's look at this vertical line. Should only hit my graph once. Look at this other vertical line. Another vertical line. So yes, this is a function. Why? Because of the same reasoning. Now what if I gave you this? There's my function. Look at this vertical line. Ooh, you notice how it hits it here and here? So we would say, no, not a function. Why? Because it does not pass the vertical line test. So now we're saying, okay, let's take a look at these functions. And again, I kind of want you to get in the habit of visually speaking. Do you know what the square root looks like? Like that. It kind of starts and then kind of moves over to the right and up a little bit. But what I'm saying is, I don't want you to figure out what each value is. Okay, I don't want this whole table. I don't want to know all these separate numbers. No, 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 no. I just want one answer. I want to know what f of 6 is, which means when x is 6, I want to know what y is. That's all I'm asking. So this is how we write it. We say f of 6 equals square root. Instead of x, put a 6 in its place. All right, so we got 6 plus 3, and the square root of 9 is 3. So I would say f of 6 equals 3. Or I could write it as a coordinate, 6, 3. All right, now this is called a piecewise function. You dealt with this a little bit in Algebra 2. I'm not sure about pre-calc. I'm assuming so, but I'm not really sure. And it's saying, okay, look at this parabola. This is a parabola. Hopefully you recognize that. But I only want you to use this parabola or look at this parabola when your x value is less than or equal to 1. Okay, if your x value is bigger than 1, then I want you to look at this parabola. So it depends on which parabola you're looking at. So pick the piece. You can't use both of these at the same time. Pick one. And all depends on this. So they're saying find f of 0. Well, where is f of 0? Where is 0? What piece does it fall under? Does it fall under this section or this section? So take a minute and think about that. Where is 0? Is 0 less than or equal to 1? Or is 0 bigger than 1? Okay, well 0 is less than or equal to 1. So we are not going to use this at all. Do not even look at that. I'm going to cross it off altogether. Look at this one. So when I say f of 0, I need to use the top equation only. And I'm going to plug a 0 in for x. So I'm going to say f of 0 is 1. Or I could write it as a coordinate, 0, 1. Okay. Now this gets a little tricky, so you got to pay attention here. So it says, here's my function, x cubed minus x. But this is what I want you to do. I want you to find the original function, f of x, minus the function using 1 where there is an x, all over x minus 1. So you notice how these ones have the f out in front? That means that you're going to do something with a function here. If it doesn't have an f out in front like this one, you're not going to do anything down here. So we're going to do f of x, which means the original function, minus f of 1, which means plug 1 into the function, all over x minus 1. Now again, we're not doing anything with that denominator because there's no f out in front. We're just going to leave it as x minus 1. So what is my original function? My original function is x cubed minus x, minus. Now I need to do f of 1. Well, usually I do that off to the side. I'm going to do this. F of 1 equals, I'm going to plug a 1 in wherever there's an x. 1 cubed minus 1. Well, 1 cubed is 1, minus 1 is 0. So really I'd be subtracting 0 here. All over x minus 1. All right, so let's clean it up. Let's simplify. And now let's keep going. You notice the top is a binomial. I can factor stuff out. I can factor out an x, and that will leave me with x squared minus 1. And let's kind of take it back to algebra 2. These are binomials, and because they're not identical, we can't start crossing stuff out. So what I can do, though, is I can still factor the top even more. I can now factor this parenthesis x squared minus 1 into 2 more parentheses because these are perfect cubes. Sorry, perfect squares. X, and a minus 1 and a plus 1. All over. Now do you notice that this binomial x minus 1 in parentheses is the same as this binomial x minus 1 in parentheses? So I can cancel out the entire binomial. And that will leave me with an x, and then this x plus 1, over nothing, right? You can put over 1 if you want, but it's really not necessary. There's your final answer.